Leaching is one of the first stages of decomposition. Leaching is the rate-determining step for mass loss of plant litter when it first senesces. What this means is that the removal of soluble material is one of the first stages of decomposition, and some of the most mass loss that occurs early on occurs via leaching. Now, leaching is the removal of soluble material from litter, and that includes mineral ions and water-soluble organic carbon. So there's minerals that are going to be in the water that leaves litter, as well as dissolved organic carbon. In general, we think of leaching as being more important for nutrients than carbon, but substantial quantities of both nutrients and carbon can leave litter via leaching. It's also important to note that leaching occurs on live leaves. So it's not just a process that happens once a leaf is dead, or root or other material. It's a process that's relatively continuous. Directly after senescence is probably the time when most of the leaching occurs. That's when plants are least able to retain soluble compounds, and there would be a lot of soluble compounds left over after resorption. Now, a lot of the organic matter or organic carbon that's released via leaching is relatively labile. That means it's easy to be broken down. And so if you look in the water that drains leached litter, it often has many sugars in it and amino acids, for example, and these are readily used by microbes. So there's a strong flush of productivity in the microbial community when leaching occurs. Litter fragmentation is the second stage of decomposition. Fragmentation creates fresh surfaces for microbial colonization and increases the proportion of the litter mass that is accessible to microbial attack. So we talked about how fragmentation takes big chunks and turns it into little chunks. And by doing so, there's a lot more surface area, and microbes can now access more of the material, whereas before they wouldn't be able to get it into the middle of the larger pieces. For plants and also many animals, cuticles and lignin in the cell walls protect plants from breakdown by microbial attack. So for example, if we take a look at some of the tissues within plants, these tissues are relatively well protected. And if you were to put these directly into the soil, microbes would have a hard time getting enzymes or getting themselves into many of the spaces that are in between the materials that they would want to decompose and utilize for energy. Fragmentation increases the surface area to mass and makes those areas more accessible to microbes. It also serves the purpose of inoculating much of the organic matter with microbes and bringing microbes closer to the point of decomposition. Soil invertebrates in many ecosystems are very important for fragmentation, and they're one of the first lines by which organic matter gets fragmented. Now, there are differences among ecosystems in the relative importance of soil invertebrates, and they tend to be more important in warmer than colder ecosystems. But still, soil invertebrates are an important component